Carnot principle states that, for a given hot and cold reservoir, no engine can have more efficiency than a reversible Carnot engine. Clausius inequality is just another way of saying the same thing. It states that for a given thermodynamic cycle, sigma Q by T is less than or equal to 0, where Q is the heat exchanged from the reservoir, and T is the temperature of the reservoir. To see why this is true, we can look at the LHS, considering the cycle of a heat engine, where heat transfer happens twice. Once from the hot reservoir at temperature TH, and then to the cold reservoir at temperature TC. Here the heat QH is being added to the engine, and so is positive, while QC is being rejected by the engine, and so is negative. There are two possible options here. Either the engine is ideal and reversible, or it is an irreversible engine. Both will have the same heat input, but are able to extract different amounts of work. Correspondingly, they reject different amounts of heat QC to the cold reservoir. In the case of an ideal reversible heat engine, the heat transfer depends only on the temperature of the reservoirs. And so we have the relation, QH by QC is equal to TH by TC. We can rearrange this to the form of the earlier equation, which gives us QH by TH minus QC by TC is equal to 0 for a reversible process. Or in other words, sigma Q by T is equal to 0 for a reversible process. If we look at the irreversible engine, it has less efficiency than the reversible engine. So it will extract less work, and reject more heat, compared to the reversible engine. If we divide both sides by TC, multiply by -1, and then add QH by TH, we can get the form of the earlier equation. But we already proved that this equation is equal to 0 for a reversible process. So for an irreversible engine, QH by TH minus QC by TC is always less than 0. Or in other words, sigma Q by T is less than 0 for an irreversible engine. Combining these two together, we get the general form, sigma Q by T is less than or equal to 0, which is known as Clausius inequality.